good morning, afternoon, or evening, Algebra 1, depending on when you're watching this video. I want to hope you guys are having a great snow day. This is meant for Friday, January 10th, the class that we are sadly missing due to whatever snowstorm's going on. I'm recording this Wednesday, January 8th in the morning, so I'm not sure if we have snow yet, but hopefully as we're watching this, there's a bunch of snow on the ground. Maybe take some time, make some snow ice cream, go sledding, have a snowball fight, enjoy yourselves, okay? Today we're going to work through pages 18 and 19 in our booklets. This is going to correspond to kind of the fourth main topic. We've learned about graphing, we've learned about substitution, we've learned a little bit about elimination, and now we're going to kind of pick it up and learn a little bit more about elimination and some different scenarios that could occur. Reminders, after watching this video, hopefully you should complete homework number 4, which will be due on Tuesday. In addition, hopefully this video is you're watching it on Friday because your IXL skills are due today at 3 o'clock. If you've already done those, good work. So we are going to jump right in and figure out how to work with what if we have no common coefficients when we are solving a system of equations using elimination. So as we learned on Wednesday, we can solve systems of equations by using the process of elimination. To do that, we take one equation and we try and get similar variables so that they'll cancel out. We can eliminate one variable. That's the goal. But we never really ran into situations where we had different coefficients. And so what we're going to do in this scenario where we have different coefficients, or in this case no common coefficients, is we are going to multiply one or both of our equations by some number to create what we call matching opposite coefficients. Take a moment, pause the video, and write that down. Okay, now that you've written that down, we're going to actually explore this through problem number 1. In this case, I have an x plus 3y equals 6 and a 2x minus 7y equals negative 1. This is indeed a system of equations, and our variables are lined up with the x's together, the y's together, and our constant terms together. What we're going to do is let's investigate these two equations. If we were not required to use elimination, it would probably be good to solve for x and substitute and use a substitution method for x. But we're required to use the process of elimination. And so what we're going to do is we're actually going to do this really weird thing. So you remember that term matching opposite coefficients from above? That's what we want to create. So I want to find which of these two coefficients look like the easiest to work with to get matching opposite coefficients. I think this first set, the x's, I think we can hopefully eliminate using this method. And so here's what we're going to suggest. My lower coefficient is 2. What if we multiplied 2 by the entire top equation? What would our resulting equation be? It would be this. 2x plus 6y equals 12. Let's continue by copying down our other equation. And I have 2x and 2x. I want to get rid of a variable. That is the entire purpose of using the elimination method. And so let's eliminate the x's. Well, if I add these two equations together, is that going to eliminate x? No. But what if I subtracted? If I subtract the top equation, equation number 1, from equation number 2, what is our result? Well, let's figure it out. 2x minus 2x gives me what? 0x. That was our goal. Very good. What about 6y minus a negative 7y? Take a moment. 6 minus negative 7. That's going to be a positive 13y. And then what is 12 minus negative 1? Well, that's going to be equal to a positive 13. Now what we can do is we can actually solve this for y. Well, the 0x does not matter. To get y by itself, let's divide by 13, and we come to find that y is equal to 1. Just like in the substitution method, we know these two lines, or these two equations, must intersect at a point, and that point has coordinates. We have found half of the solution. We know some number, comma 1, is the actual intersection point of these two lines, aka the solution of the system of equations. Now that we found y, we can actually go back and plug that in, and we can find x. I'm going to pick your poison on the equations. I'm personally going to choose the top equation here. And what's going to happen when I do that? I'm going to be left with this. X plus 3, what is y? We just found it to be 1. 3 times 1 is equal to 6. So x plus 3 is equal to 6, subtract 3, and I'm left with x is equal to 3. Now I can plug that in, and we have our answer. The solution to this system of equations is the coordinate 3, 1. And that's it. Our goal is to, with these problems, look at the coefficients and find a way to create matching opposite coefficients. In this case, 2x and negative 2x are what we're going to call opposite matching coefficients. Let's skip down to number 3, for example, and let's figure out what we can do here. So let's investigate both of these. Is there a way that we could possibly create opposite matching coefficients? There is, and I think hopefully it pops out to y'all pretty quickly, but we have this negative 1y and this 4y, and I typically like to pick the variable that has 1 already solved by itself. So for example, there's a 1 here. I think that's pretty easy to work with. So we're going to eliminate the y's. That's the variable we want to eliminate. And so what do I need to multiply either the top or bottom row to eliminate one of them? Well, I see a 4 here, and it's positive. What if we got a negative 4 up top? Would that eliminate the y's? It indeed would. So let's multiply our entire top equation by 4. When I do that, my resulting equation is this. 12x minus 4y is equal to 14 times 4. Let's find out. That is a 56. Once I do that, what we are going to have on the bottom left is obviously 5x plus 4y is equal to 12. Now let's just pause and make sure our variables are lined up. They indeed are. And what operation am I going to need to get rid of negative 4y and a positive 4x? Well, we're going to need to add these two equations. So once we do that, 12x plus 5x should give us, very good, 17x. Negative 4y plus a positive 4y, that goes to 0. And that's all equal to 56 plus 12, which is going to be 68. Now, to solve for x, we have the equation 17x equals 68, and we can divide both sides by 17 to find that x is going to be equal to 4, if I did that math right. Again, we have half of our problem solved. We know that our x-coordinate is going to be 4, but what's our y-coordinate? Well, we can find it by taking this value we just found and plugging it back in to one of our equations. So I'm actually going to take this 4 and I'm going to plug it in to this x right up here. So we can solve for y. Here we go. 3 times 4 minus y is equal to 14. Solving for y, we get 12 minus y equals 14. Let's subtract 12 from both sides. I get negative y is equal to 2. And in order to get y by itself, let's divide by negative 1 because it's being multiplied secretly. And we get y is equal to negative 2. From there, let me get a bigger highlighter. From there, we can plug this back in, and now we have our intersection point. 4, comma, negative 2. And we're done. That's it. Now, let's go look at an example where we have to multiply actually both equations, top and bottom, by a number. Here it was pretty nice. We had a 1 and we could just multiply. But, for example, follow me to page 19 and let's look at problem number 8. Problem number 8 is interesting because it seems like there is nothing in the world that we can do here. In this case, when there's not like 4 and 3, I can't multiply 3 by 2 to get a 6. There's a 5 there. I can't multiply, 3 by 1/4 or whatever. I could. It would make our math pretty gross. Here's what I'm going to suggest we do. Why don't we just multiply, pick a letter, x or y, doesn't matter. We have 3 and 5 as our coefficients for x, and 3 and 4 as our coefficients for y. Let's actually get rid of y here. Those numbers are slightly smaller, so maybe it'll be easier for us, okay? Here's what we're going to do. Take your coefficient of the bottom equation, and let's multiply the entire top equation by that. I know when I do that, I will have the top equation will then be a multiple of the bottom equation, at least for the variable y. Same thing, my top equation's coefficient on y is 3. So let's multiply our bottom equation by 3. Once we do that, which, takes some time, make sure you multiply this coefficient to every single term. Distribute. My 6th graders, fun fact, learned that today. So multiplying the top equation all by 4, which again was the bottom's equation's coefficient, we get this. 12x plus 12y equals 9 times 4, I think, is 36, if I'm not mistaken. It's been a minute. And then multiplying the bottom equation out by 3, I get 15x plus 12y equals 30. And now the reason we did that is because now I have the system of equations with 2 equations where the coefficients of my y's are both the same number. We can handle this situation. If we subtract the 2 equations, we can get rid of the bottom one, thus eliminating one of our variables. So 12x minus 15x is a negative 3x. 12y minus 12y is going to be a 0y, so it is gone. Thank you, that's the point. And then 36 minus 30 is going to be equal to positive 6. Very good. From here, we can divide both sides by negative 3 to solve for x. In this case, x is going to be 2. Negative 2. Negative 3 divided by 6 is a negative 2. And again, we have half of our problem, so we take this x and plug it back in. I'm going to plug it back into the top equation just because it seems a little bit simpler. And what we are going to plug it into is we're going to plug it into the original equation. So I'm plugging this, just for clarification's sake, back into 3x plus 3y equals 9. When I do that, I get 3 times negative 2 plus 3y equals 9. Solving this, I get negative 6 plus 3y equals 9. Add 6 to both sides. I get 3y is equal to 9 plus 6 is 15. Divide by 3. And I get y is equal to 5. I have my x. I have my y. I can write a solution in the form of a coordinate, which, if we remember, is where these 2 lines intersect at. That's what we just found, their intersection point. And that coordinate is negative 2, 5. Hope this video helped. The solutions for this entire packet, numbers 1 through 12, are in Schoology. If you have any questions, please reach out. And hope you guys have a great snow day. See you Tuesday with homework 4 done. Mr. Bivens out.